A warm welcome also from my side. I'm very proud to present our paper in behalf of the Alpha team. So I want to give you at first an overview. What is the context this paper has emerged? Then I want to give you the general idea and the general architecture of the paper. And then I will give you examples on which you can see how the development was performed and how the idea has evolved. And within all these aspects, I will explain you in detail how we developed these ideas. So at first, I'm part of the research project Robotop, and within we have the task of system architecture and configuration. So the part I present will be mainly focused on configuration and the system architecture, and within on the VR configuration and classical planning approaches for robot-based automation solutions. The general research project Robotop is thereby focused on the easy automation. So we want to enable SMEs to get an easy start with a robot-based automation solution. And for this, we want to provide a web-based configurator to make the whole configuration process easier to understand, more accessible. And so we focus on a constraint-based and best practice-based configuration. But how does this fit together with the VR configuration? So when you see the 3 levels of usability, the first level is effectiveness, the second level is efficiency, and the third level is satisfaction. And as you see, within efficiency is based on our user-centered approaches, and satisfaction is reached with VR. And this was the experience through the whole processes we observed, that the first 2 processes are necessary to fulfill the task, but the second one makes it easier and faster, and the third one involves the people. So a lot of managers and all the people are very interested in this stuff, and we also get students more involved, and we could easily communicate our ideas. And also we published these ideas in another paper where we received the Best Paper Award for. But we focus on the VR. And to structure the use cases of VR application, we developed 7 levels of detail. Background was I was walking like on the Automatica or on other industrial fairs, and there was a problem. I saw a lot of VR demonstrators. I saw a lot of AR demonstrators, but it was hard to understand. Everyone has a little bit VR interaction. Everyone has some functionality, but I didn't see any application where a whole setup was shown. And also, nobody could tell you how much was the development effort and stuff like that. And so the idea emerged that we have to structure these use cases, because a lot of people I talk to, when they develop VR and AR application, they say bringing in intelligence, more usability is a lot of hard work, because you have to integrate more logic, more intelligence. And on the other hand, you don't need for every application the whole setup. So sometimes a 3D shape or 3D shape with a texture is enough. A 3D model, which you can download from websites, is sometimes also enough. With 3D models, you have to reduce sometimes the object size, so you can render it like in web application, but it's just straightforward. When you do more advanced stuff like kinematics of the 3D model, it's some preparation, because you normally don't get kinematic models, so you have to kinematicize the models, or if you want to generate animations, you have build these animations on your own. More advanced you get with RCS modules, so you have to build like an inverse kinematics of the robot, and then you have to couple these with the model, and this is some advanced robotics, and not so straightforward and not freely available. So you can pay for the RCS modules from the companies. So robot companies have for all their robots RCS models, but they are normally not free and not easily integratable in every kind of software. but with REST APIs, there are some possibilities to couple them. And more advanced, like smart modules. They are on the one hand from the engine, so the engine has a physics components, but you can also like interfaces, intelligent smart logics of the object, so you can advance these models like in every direction. So if you want to have more usability and more user interaction, and especially the interaction where like the robot moves was recommended as very nice, then you need these kinds of models. But as I mentioned, for easy small application, it's not always necessary. So to validate and also to structure it and to get the ideas more accessible, we take two use cases. The first use case is the VR planning concept of robot-based automation solution. So within, we build it on a 3GS base. This gives us more flexibility in building the solution, also to integrate new functions, to experiment, to condense ideas. And on the other hand, to also show that it's very important for industrial application, also accessible. We used an industrial setting with a Siemens Technomatics environment. But at first, I want to start with the VR use case 1, because this is the general structure and the other one is just the advanced. And there you see what kind of models are integrated within the software. To show it, we built a 3D environment like a virtual tour. And along this virtual tour, we arranged, on the one hand side, the classical planning approach to show people how classical planning is performed. And within, we integrated the VR interaction. And on the other side, we also integrated the new planning approach from Robotop, the best practice-based adaptation configuration, which is much more efficient than the other approach. And the last demo station, we also show the different level of details within the area. For user interaction, we used HTC Vive Pro and within a 2 controller. And like in a VR environment, you can integrate different kinds of displays. So also user interaction is much different and it's necessary to move your controller, not like a 2D environment. So the first scenario is done with this kind of controlling. First station or second station is just a concept planning, a Kanban board. It's like a real Kanban board, but you have the advantage if you pin it, you can automatically connect this with a database. So you have advantages of real environment and database environment. So you can track it on the background with a classical IT tool, but you also can visualize it like a normal Kanban board. And also multiple persons can be working in front of these. So there's a lot of advantage doing Kanban boards also in a VR environment, especially with data integration. The third station is the classical planning approach according to Helbig. According to Helbig, we can just structure it in the process model, then the station model and the detailed station model. So within these models, the idea of an automation solution gets visualized. You see what's the layout and what kind of functions is needed. To get more concrete, 3D models can be integrated, and within we show like 3D model and also we animated it here. So you can interact with the VR scene. You can like add additional information with 3D painting as you see, and like set markers, so there is a possible collision or stuff like that. So you get a good real impression how the automation work is done and how, maybe also the scene can be further developed, because like maybe you need here a tray or an FTS is adapted here. So for additional material transports, and you can visualize your ideas very fast and can communicate it very easily. And so you can combine the 3D visualization with the 3D drawing and adding functionality. You can also add 3D objects. So it's very fast and easy for communication. The second one is the teaching. So when you visualized. You can also teach your robot. For this, you need an inverse kinematics. You can do it on 3 ways. You can just save trajectory points, and then the robot is going from trajectory point to trajectory point. What is much more easier to implement is that you just record. So you don't need especially an inverse kinematics. You can just record the movement, and then the robot can just playback it. But if you want to take the robot and grip it, you need an inverse kinematics again. So just take the trajectory points, leads the robot. He saves the point, as you see, and then you can play it. And for this, inverse kinematics is mandatory. The 7th station is like the best practice. So the best practice based planning is based on knowledge which is acquired in previous projects and is structured within a database. And so you don't do the whole planning stuff. Especially it's too hard for SMEs with low experience in automation. You just select the best practice which fits best your solution, and then you adapt these. So you change the robot model, you change a little bit the layout, and so you're much faster. You don't start from scratch. You start more from the back end. The second use case was done with the Siemens Technomatics. Within it was like a human-robot collaboration, so it was more a detailed observation of existing automation solutions. So if there is a collision with a human, is safety working, and also integrating it in a real industrial toolkit. The whole virtual commissioning stuff is done within this approach. So to conclude, we could say you can structure the use cases along the LOD approach. It is very useful to understand it, especially in the last example you saw. It is that you integrate the stuff into the Siemens environment, and therefore Siemens gives you a lot of tools from where you can use it. So the inverse kinematics is also there. When you develop it from scratch, it's much harder. And also the use case specifics is that you want to know what is your user interaction. So for concept planning, a hand tracking with controller is enough. If you're doing more detailed stuff like Kinect 2 for body motion control and the leap motion control for hand integration is very, very useful. So also the hardware setup is depending on the kind of application and use case you're developing. To take a step further, you can integrate these planning approaches with a process-driven approach. We also show in another paper on the CIRPe conference this year. And so you can automate the processes within this whole approach with a process engine. At the moment, it's much hard-coded, and for further research, it is very useful, like to build all the workflows within a process engine, and so it is much easier to automate. Thank you for your attention. If you have further questions, don't hesitate to contact me. Also stay in touch, add me on ResearchGate or LinkedIn, so we can share future research.